Hello, in this video we will continue our work on problem 1037. You have in your screen the addresses where you can find the solution that we made by hand and the first part that we made in ease. In the second part we are going to explore some features of ease like doing the parametric tables to find out the effect of the moisture content allowed at the end of the expansion, and how to use lookup tables, which are a little bit different from parametric tables and let us to combine results of different runs. Okay guys, I hope you enjoyed this one. We can see that our pressure is 2141 kilopascal, which is 2.14. It's very close to 2.34 that we have in our solution. This will be a bit more exact since we are we're computing the exact properties at each iteration, opposite to the interpolation that we did in our solution. So we're not going to compute the efficiency, but instead of that we are going to, or the heat, that will be the same procedure. But what we are going to do is to do some exploring. We would like to get some insight from this. For instance, what do you think it will happen if we change this maximum moisture content? Well, let's see. We can make this comment, and we're going to build our parametric table. We're going to build our parametric table. We're going to change this enthalpy and see how pressure 5 varies. Okay. I'm going to say that the last value is 1, that is saturated, and that the first value is 0.9. Let's say then is 0.21. It's 0.80. 0.82, so we have an even number. Then we press F5, F3, and we can see that as we are approaching to saturated, we need to extract the vapor earlier. So if we wait until we have pretty much expanded, then we're gonna end with higher content of moisture. We can plot this to understand a little bit better, and you can see that it's not a perfect curve. I mean, it's not a line, it's a curve. And that's the one thing we can compute efficiency to see the effect on efficiency. So we have Q in to be, we're not going to use the mass flow rate at this point, but it will be H3 minus H2 plus H5 minus H4. W of the turbine will be H3 minus H4 plus H5 minus H6. Work of the pump, we already know it, and this doesn't change with this, where we can compute W net equals to sorry, work of the turbine minus work of the pump. Check it for original problem just to make sure that we have the same value. We notice, oh, I forgot the eta. Work net divided by Qin. So we notice this is close, 42.6 versus 41.95. Again, the difference is in the numbers that we are using. In the manual solution we are using interpolation. So now we make this a comment again, and we add some variables to our run. Tables, insert variables, and we would like to have the efficiency also. F3, we have it. Oh, we didn't add it. Add variables, data, yes, okay. Now we have it, F3. And we can overlay this plot. Instead of creating a new one, we're going to overlay this plot, and we're going to do it in the right Y scale. We can see that our efficiency it's a maximum. We have this 0.86 kilopascal quality, because that corresponds to, let me add some notes here. So this maximum is 0.4, which is close to the 1 to 4 kilopascal, which is close to the 1/4 that we have it in our textbook. So you see that you can work with this and say, okay, I would like to have maximum efficiency for this reheat cycle. I have this problem of the maximum moisture content that is limited to 9. Well, we can now change. We know that if we have a higher pressure, let's change this to 20. We know that we are going to have, let me make an automatic update for rows and automatic update for all data. So now when we solve it, instead of 20, it will be you can see that now our efficiency is changing here. Let me read the automatic scaling. So now my efficiency has moved to the right, closer to the 90, right? So we are gonna, and this 90% of quality could be an instruction of the fabricant of the manufacturer of the turbine. So we are gonna do one last thing. Let's change it to 30, and it could be any number, right? 37, let's say. Notice that this is now on 88, and we can just press F3. Run. The moment we pick here, we are see how this moves, and that's the way that we can do this more appealing. We're going to create some liquid table 10 4. Okay, have that. We now copy the efficiency. Have that. We change the name of this. And we're going to repeat our analysis for different pressures. So now this is 20, F3. We just copy it and the efficiencies, and we move to lookup table to paste, and then we repeat the first one. So F3, okay, copy the efficiencies, go to lookup table 2, and we are gonna alter values, no, properties, sorry. So we said that this is quality 6. We said that this is P condenser equal to 10 kilopascal. Okay. Properties, change this. So this is 20. Properties, and this is 37. So now we can manipulate this table as any other table and create a plot, XY plot, and instead of parametric we'll set with lookup table, and we're going to use lookup table 2, and I have the data here. Oh, gosh. Let's do this right. Properties, this is the title. Not a unit. So we can do this to look nice, as we're going to do it. Okay, so now we come back, plot. Go in this lookup table, table 2. We're going to have this stream. We're going to add the legend, spline line to make it look nicer. And what we're going to do is P count and the units. Change this. This is just aesthetics. So we can see now that I'm gonna add some symbols just to make sure that we can identify. This is a triangle. And we're gonna add them. Sorry about that. So I'm going to change this from, okay, so we can see that the maximum, which is here, moves to the left, maximum efficiency, as we increase the pressure, which is expected, because if we want to conserve the 90 degrees, we're going to add some grid lines just to make sure we see everything. Let me see if I remember correctly how to do it. Okay, we're gonna move this. I think that we need to take out this part. No. Okay, here you have you. Press 1 and then right mouse click. I'll say add grid lines. So what is the insight that we are gaining is that if what is important is to preserve our quality at the exit, we need to increase the pressure. That will move our efficiency to the left, to the right. But at the same time, the efficiency will drop, which is what we expected because we need to increase the pressure of the condenser so we can have less moisture content at the exit of the turbine. But that's something that we already knew. Okay guys, I hope you enjoyed this video. That's it. Thank you very much. Bye.